was 2 degrees below zero. The temperature drops by 5 degrees. What is the temperature now? So if we are at 2, -2, and it drops 5, that means we are going in this direction, the colder direction. So we need to go, so this is, right, so it's going by 1, 2, 3, 4. So 1, 2, 3, 4, 5. And that would put me at -7. So what is the temperature now? It should be -7. Okay? All right, put those up, and you're going to open your books to page 349. 349. All right, let's see what's in the chat. Somebody put something in the chat. Okay.
It's somebody asking for the audio, or who missed the audio on the bell ringer. Their audio must be cut out.
Oh. That's weird because it hasn't even... Oh. No, she said she's about to watch. She was here for testing. But if you missed it, guys, here is the bell ringers. So it should be C and -7. All right, so this is the last lesson in this topic, and it is a one-day lesson. All right, so we are going to use what we have learned about the area of our cross sections and circles to do what we call composite figures. So basically a composite figure is basically a figure that has been combined by 2 or more different shapes. So if you can see from the first one, if I draw a line here, this figure is made up of a triangle and a rectangle. Okay? So it says, Rahim drew an outline of the front of his house on grid paper. He wants to find the area of his model. So it says, separate the composite figures into simple geometric figures. What simple geometric figure are used from the outline? Okay, well, we know that it's a triangle. So 1, 2, 3, 4, 5, 6, 7. So my length is 7. Sorry, I had to see what it was going through. One, 2, 3, 4. I think that's too big. This is why I don't like using those pens, because it doesn't erase. That one don't work either. I'm batting 1,000 on pens. Okay, so we know that this is 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so this is the rectangle, right? And then my triangle, I just drew it 1 too far. Should look like this, right? Yep. Should go from there to here. Sorry, I can't draw it. All right, so if I separate them, it should look something like the purple. So ignore this line right there. Okay, so my dimensions are a 3 by 5 on this one. My height is 2. And this one should be 1, 2, 3, 4, 5, 6, 7. Should be a 7. Okay, so determine the dimensions and then find the area of each shape. So the triangle is a 7 by 2. And remember, triangle is length times width divided by 2. Or you can say base times height times 1/2. That works too. So either one of those would work. Okay, and then the rectangle is a 5 by 3. So if we're finding the area, we would have 7 times 2 divided by 2, which is 7. And then here we would have a 5 by 3, which is 15. Okay? So the area of the composite figure, which is the whole entire thing, would be a 15 plus 7, which is 22 units squared. Because remember, anytime we find area, it's always square units. All right, so the turn and talk says, can you separate the composite figure into different simple geometric figures? Okay, well, let me go back up. So I could, if I left that line there, right, I could split that in half, and I could make 2 triangles. I mean, if I really wanted to, I can make them into smaller rectangles. So that answer would be yes. So we could make smaller triangles and rectangles. All right, so moving on. All right, so hopefully you can see that this composite figure is made up of a rectangle and a semicircle. So it says determine the simple geometric figures that are used. So we have a rectangle and semicircle. Okay, find the dimensions of the geometric figures. So the rectangle would be a 12 by 19. And the semicircle would have a diameter of 12. Okay, and that's really all we need to find the area. Okay, so how is the area of a semicircle related to the area of a circle? Well, how is it related? Anybody have any ideas? How's it related?
Does it have something to do with the diameter?
Yep. Has something to do with the formula. So the formula for the area is pi r squared. Okay, so let's think about it. We would use the same formula, but we would need to take half, right? Because a semicircle is half a circle. So we would need to take half of the answer. All right, so now we're going to find the area. So rectangle, how do we find the area of a rectangle? How do we find the area of a rectangle?
Okay. Hillary says something about times or multiplication.
Yep, I see times. You're right, times, but what are we timesing? It's a rectangle. How do we find the area? What are we multiplying? Come on, guys. This area of a rectangle is not a 7th grade standard. It's like a 4th or 5th grade standard. Thank you. Yes, Hillary. 19 times 12. So what is 19 times 12? Come on, guys. Thank you, Jacoby. 228. Thank you, Julian. Thank you. All right, now we find the circle. And the circle is pi r squared. We have the diameter, which is 12. So the radius is half, which is 6. So we're going to substitute it in. So 3.14 times 6 squared. So that means 3.14 times 6 times 6. Semicircle, so we're going to divide by 2. What do we get?
$56.52.
56.52. Okay, does it tell us to round? What does it tell us to round to?
Nearest square foot.
Yep, so what would I round this to? 50 what?
57.
Yep, 57. 57. Awesome. All right, so now we're going to find the area of the entire thing together. So 228 plus 57.
$285.
Yep. Since it is area, it's feet squared. Thank you, Terrion. All right, so the turn and talk. What method do you use to determine the simple geometric figures of a composite figure? So what they're asking you is, what did we do? So to get the area of this whole thing, what did we have to do? We had to break it down to figures that we know how to use the area formula for, right? So we had to break it down to a circle, so we know how to use the circle formula. We had to break it down to rectangle, had to break it down to triangles. So we got to break it down and use the formulas that we know. Okay? All right, so let's look at 3. 3 says the manager of the hotel wants to put carpet in the lobby. The dimensions of the lobby are shown. There is a statue with a circular base in the lobby that does not need to have carpet. So here is that piece right there. All right, so what figures do we have? So what do we have? What can I break this down to? I know one of it's there. So if I break it there, what do I have? So this bottom piece is a rectangle, right? What are my dimensions of that rectangle?
Wait, could you ask that question again?
What are the dimensions of this rectangle?
Man, it's gonna be hard. I haven't been here this meeting for days.
Well, look at it, Samir. What is the bottom? What is the base?
Oh, it's 30 feet.
Yeah. What is the height?
9 feet.
Yeah. So it's a 30 by 9.
Yeah.
So 30 by 9. Okay?
But what about the 15 feet, though?
What about what? So the 15 feet is the entire thing. So what we're going to use that for is we're going to use that for the height of my trapezoid, because this is a trapezoid, right? So if I take the 15 and I subtract 9, what do I get?
You guess 6.
Yep. So that means the height of my trapezoid is 6. Okay?
Oh, I understand now.
Good. All right. So my dimensions of the trapezoid would be 30 is my base. My other base, so we're going to call that base 1, right? My other base is 24. We're going to call that base 2. And the height, which you told me, is 6.
Okay.
Okay? All right. And then my circle, what do we know about the circle? What do we have?
4 feet.
And that is the diameter. So the diameter is 4. All right, so now we're going to find the areas. So we know a rectangle is just length times width, base times height, however you want to do it. So 30 times 9, so what do I get on that one?
270.
Yep.
Wait.
That's right.
Right?
You were right. 270. Okay. Now, trapezoid, that formula is B1 plus B2 divided by 2 times the height. So we know this one. So B1 is 30. B2 is 24. And we know the height is 6. So 30 plus 24.
So it's 54 divided by 2.
Yep.
Times 6.
Yep. So what's 54 divided by 2?
17.
27, yep.
27.
And then we're going to times that by 6. Yep. Awesome. All right, so now we're going to find the area of the circle. So remember, circle is pi r squared. So we know the diameter is 4, so the radius is half. So that's 2. So my circle would be 3.14 times 2 times 2. So what do we get?
$12.56.
Yep, approximately 12.56. All right. So now we want to find all the shaded minus that circle. So we're going to take 270, 162, and we're going to subtract 12.56.
Lavelle,
Yes.
could you also have taken the whole figure and subtracted the small triangles at the top?
Yeah, I could have made it 2 rectangles.
I got 419.44.
Yes. Yes, 419.44. Does everybody understand what Miss Capel was asking? So instead of a trapezoid, I could have cut them here, and then I would have had a rectangle, 2 triangles.
I was actually thinking, Miss Lavelle, of going 15 times 30, then subtracting. I
Oh,
think it's a 3 by
yeah, you could do it that way too.
3 by whatever. Just
Yeah. So y'all see what she's saying? So
Yeah,
if I extend this, we end up with one big rectangle. And then we would just subtract the 2 triangles. So yeah, that would work as well. Okay? All right. So what I want you guys to do, because we don't really have a lot of time to do the check understanding, is I do want you to move on to the on your own. Okay? We have about 20 minutes. So I want you guys to work on 4. I want you to do 5, 6, and 8. So 4, 5, 6, and 8. And that is on page 352. So 4, 5, 6, and 8. Okay? And once again, I'm still here. I'm live. So if you need help, that is what Miss Capel and I are here.